We are going to do a classwork problem in the section 15.4. The problem is number 15.9. There are two subparts. I'll show you A, and then you can follow the exact formats to do B. So what's the question about? What are we measuring? Well, so let's take a look. So we're measuring actually this time the cholesterol level of all men. And we are told that the cholesterol level of all men follows the normal distribution. And then subpart A asks you to choose a sample of size 100 and asks you about two things. One is the sampling distribution of the sample mean, and the second part asks you the probability that the sample mean or any randomly selected sample mean will have a value between this and that. Okay, so let's just do the first part of the subpart A. So let me bring up my demonstration. Now, so you don't have to type. You just need to you don't need to type. Just write on a piece of paper, but make sure you copy the exact format below, fill in the blanks, because that's how the grader is going to grade your work. Okay. So the first part of subpart A. First thing is, whenever we do problems like this one, we need to be sure what are we exactly measuring. So what does X represent? So then you fill in the blanks. You fill in the blanks. So X represents the cholesterol level of a man aged between 20 to, is it 34? Yeah, 34. Where is it? Where's mine? Okay, 34. Okay. So hopefully your handwriting is better than mine. Now, so when they say the distribution, when they ask you about the sampling distribution, they're basically asking you about three things. One is, what's the center of all possible sample means for a certain size? And what's the standard deviation for all those samples from a certain size? And what's the shape for all those samples? When you try to do a histogram of all the sample means from all those samples, what's the shape? Okay, so three things here. Now, since X is normal, then we know that sample mean, the distribution of the sample mean is also normal. That means if X is normal, when you have many sample means, these sample means is also normally distributed. So what is the center of all the X values? So I think we are, let me make this smaller. So we are told that X itself, the population itself, has a mean of 182. So 182 is the average of all the cholesterol levels. Okay, so mu is the population mean, and sigma is the population standard deviation. So X here is the mean of X is 182. So 182. And the standard deviation of X is 37. And when it comes to the distribution of the sample mean, what is the center of all these sample means? It is from one of our mathematical facts, it is mu. And the standard deviation of all these sample means is sigma divided by square root of n. That is, mu is 182. Sigma is 37 divided by n. What is the sample size? We are only asked to draw one sample, but when we are asked about the sampling distribution, we imagine we take many samples of the same size, of the size 100. Okay, so n is 100. Okay, then if you use your calculator, so this will be 3.7. Okay, so this is how you determine the sampling distribution of the sample mean. the center of all these sample means is still mu, but the standard deviation of all these sample means is not sigma anymore. It's sigma divided by square root of n. Okay. Now next, I would like you to draw two diagrams to make sure that we really understand excuse me, these concepts. So this is x normally distributed. The mu is 182. So mu is 182. Sigma is 37. And next, I'd like you to draw a diagram for the histogram of all the sample means. Now you notice that the standard deviation, meaning this number, right? 3.7 is the standard deviation of all the sample means. This number is smaller than 37, so sigma is always bigger than sigma divided by square root of n. So that means x itself, how spread out it is, around roughly the standard deviation is 37. But x bar itself, how spread out the x bar values are, is smaller, 3.7. So that's why the diagram for the x bar is going to be narrower. It's going to be narrower. So maybe this is not, let me just do a better job. So let me get rid of all this because it's kind of crowded here. Okay, so if you want to draw this diagram, so I think I should make it narrower. So just more or less, it's narrower. And then hopefully you draw better than I do. So the middle part is still mu. This is pretty ugly. Let me just, one more time. Let me try one more time. Okay, better. The middle part is still mu. So I should write it right here. This is mu. It's 182. So the center of both diagrams is located at 182. But the standard deviation is 3.7. Okay, so the standard deviation of all sample means now is 3.7. So make sure you label the two diagrams. This is x bar, this is x. So this is how you do the first part of subpart A.